Hello, everybody. This is Group 9, and our project is called Spotlight. This project is done by Jesse Sam, Salvador Del Rio Torres, myself, and Harnik Palmer. First, we will start with the team roles. As you can see, Harry was the main coder slash builder, Jesse was the secondary coder slash editor, Salvador was the main planner and designer, and I was the main editor and the presentation. Okay. In our lifetime, there have been many casualties that occurred due to hazardous events involving failure of security systems, false alarms, etc. One example of these events are such as Eskom's $16 billion power plant's warning system failing, which caused congestion of coal and leaving the power plant with insufficient fuel. Although this example didn't result in casualties, this demonstrates that many companies lack security sensors, which are ways of preventing different hazardous events from occurring. Our problem is geared towards manufacturing companies and their lack of safety, knowing the damage they can do to society. The simple hack that we have made is called Sensilight. Sensilight is a light sensor with an auto function that can detect when there is not enough light and a strobe function when the temperature has changed to its desired temp. All of this is built on a one board that is connected to a mini breadboard. We will get into more specific features of Sensilight in the next few slides, but here I wanted to explain on why Sensilight can be a solution to the problem stated in the previous slide. Sensilight has a temperature sensor which allows the LED to strobe when either the temperature in the room has exceeded the temperature set on the one board. This temperature sensor can be implemented into the manufacturing sector because there are many companies which need temperature sensors that can detect whether or not their equipment is overheating. Some examples in which Sensilight can be utilized is either at a chemical power plant or inside a server room. At chemical power plants, certain boilers should not exceed a set temperature, therefore we can program the system to have a strobe light activate once that temperature is reached. This is very similar to server rooms, which can eventually heat up as well. Using Sensilight in these manufacturing companies can allow us to prevent any hazardous disasters from occurring due to any thermal or heat explosions.
The this Sensolite will make use of the one board microcontroller to in order to control when the LED bulb turns on and off depending on how much light is detected from the light sensor and when the temperature reaches its set degree. The one board has the LED display screen where we will display the current temperature detected and the amount of light output from where the sensor using the sensors. Using the code, we set the LED bulb to turn on when there is not enough light. When there's not enough light with the auto and manual switch, there's also a strobe function which is the third button on the board where when the temperature is higher than the set temperature, the LED bulb will strobe indicating that it's too hot. Using components from the Arduino kit and the one board, we were able to construct the sensor light.
So we have three main components for the hardware. First one being the one board that controls when the LED bulb turns on and off, depending on the state it's in. Second being the toggle button, which allows users to interact with the LED switch and to switch between different states, and LEDs to light up the signal and to signal the user that the chosen state is functioning.
All right, so for our theory, the sensor light uses the light sensor with an auto function to detect when there is not enough light and strobe function when the temperature reaches a certain temperature, as well as the manual function on the one board. So with everything, a diagram of the board as well as the the methodology will be included to walk the reader through the design process. The buttons on the one board allow the user to interact with the LED. When first turned on, the board is in start state. Clicking button 1 goes into the auto phase, where the board senses the light percentage in its vicinity and automatically turns on the LED when the light percentage falls below 5%. From the auto state, button 2 goes into the manual state, where clicking button 1 turns on the LED and clicking button 4 turns off the LED as if it is just your normal on and off switch. From this state, button 3 takes it to the strobe phase. The strobe phase senses the temperature and begins a strobe effect when when the temperature is too low or too high, depending on the user's the set variable for that. From here, the user can return to the auto state by clicking the first button. So moving on to our human factor. Although Sensolite's main audience is manufacturing companies and the job sector, we have different human factors that are present in Sensolite that can make the experience much easier, such as size, safety, and productivity. Since Sensolite is small and compact, it does not interfere with the user when wanting it to have function. The size makes it more convenient for the user, especially when wanting to minimize the space taken, and can make the product applicable to spaces in which are very snug. Additionally, it does not weigh a large amount, so the user will not struggle with installing. There is also minimal electrical risk with this micro-scale experiment, therefore making it very safe for the user to use. Finally, increasing human performance is critical if we choose to take it into the job industry. Sensolite allows the user to be productive by minimizing the possible uses and buttons while maximizing performance for those states that are available to the user.
This right here is our purchase report. As you can see, if you look at the total, it is the parts altogether cost around $100. But luckily, Harnack was able to get everything free from his work, so it only made sense for him to be the main builder / coder. Next slide. This right here, based on the first round of questions in the survey, people would rather save electricity on lights that would better fit their usage and their functionalities. On these last questions, we see there's a lot of popularity towards Sensolite and its functionalities. We see that this can possibly benefit people's daily lives and make the jobs of manufacturing companies much easier. Although our initial survey was targeted towards the wrong audience, our questions still apply to our new audience, which are now manufacturing companies. This right here is our PERT chart. Once we received the assignment, we began with deciding on our project and finalizing on building the Sensolite. We started by identifying major components of our project idea and then began to do research while also trying to estimate the time needed to complete each task. After structuring our project idea, we began to gather and purchase materials. We then started to build our circuit while also doing a little bit of designing and programming. After merging the two previous tasks, we began to test our design and fix errors if needed before submitting. As you can see, we finished our project, and although a couple dates were a little off, we managed to finish on time.
Okay, so in this next slide, I have a video of the layout of the Sensolite. However, due to time constraints, I'm only going to show you the video of the actual sensors functioning. So just give me a moment. Can you guys hear that? Hello?
No.
You guys can't hear it?
No.
Still?
Yeah, no.
You guys can't hear it? All right, give me a moment. All right, what about now?
Okay,
Yeah.
All right,
so
perfect. Sorry about that.
here I'll demonstrate how our project works. So this is our code here. Just to give you a little bit of specifics, for the light temperature or the light intensity, I have it set at 5. So when the light intensity falls below 5%, the light will turn on for our first state, and for the strobe state, the temperature around in the room right now is around 81. So I have it set at 81. So when the temperature falls below 81, I can blow on it a little bit just to get it to 80, and then the strobe effect will happen. And I have flashed the code using Hyperload. Now I'll demonstrate the project here. The code is already flashed, and I'll click the reset button, and now it's starting up. And here we go. So right now it's in the start mode. Nothing is gonna happen until I click the first button here. Now, right there, you saw the LED turn on for a little bit because my hand was covering the light sensor, but it shows the LED display shows that the intensity is 8. I cover it up and it goes to 0 and the light turns on. I let go, goes back to 8 and it turns off. Next mode will be by clicking the second button. Right now, if I click the first button, the light will turn on just like a normal flashlight. Click the fourth button, turn off. And I can do that again as many times as I want. Now I'll go into the third state, which is the strobe effect. So right now the temperature is already, okay, there you go. So it rose to 81, which is the lowest it can be without the strobe effect. If I blow on the temperature or the sensor a little bit, and there you go, the LED has turned on and is back to 81, and the strobe effect happens. And then from there I could go back into the first state and continue cycling through it.
Okay, that was our video of the sensors functioning. Now we're gonna go over the testing results. So the testing that we did was just trial and error and adjusting from those errors that were given. So although the components that bought worked as planned and everything was connected and functioning, the only thing that had to be adjusted was the coding. We had to make sure when certain buttons on the one board were pressed, it wouldn't alter the function for the LED light. When the manual function we had, which is on and off, or we had to make, or for, yeah, with the manual function, we had on and off function so that it wouldn't automatically go into the outdoor strobe effect. When setting the temperature, we also had to make sure that the temperature in which the one board was set at was room temperature, therefore allowing the LED to function correctly. This temp sensor had to be set to a temperature higher than the current room temp so that the strobing wouldn't happen right away, which is shown in the video where we kept on blowing onto the temperature sensor to allow it to function. Since we have the temperature and the light output displayed on the LED display of the one board, we were able to adjust the code according to the room in which the board was present in.
Okay, so obviously Sensolite isn't perfect. Some ways that we were thinking that we can improve our invention was instead of clicking buttons to change the mode, we can utilize smartphones, tablets, and computers by converting it into a full technological interface. We also wanted to include a timer, and these timers can be utilized by manufacturing companies with all functions with their own schedules. We also wanted to put an alarm sound. Apart from utilizing LED, which can strobe, we can include an alarm sound that will notify the client of any changes via an auditory alert. Next slide. So the purpose of this project was we wanted to create a light sensor with multiple functions that include temperature sensors to indicate when the targeted temperature is reached with the one board. Apart from activating our sensors, we can also utilize a basic on and off switch for the LED. All of our functions work accordingly to how we wanted it to be, and we have learned how to use the one board better through this project. This project taught us basic circuit design, how to work with jumper cables with the breadboard using resistors, and how to program and work the one board with the one board microcontroller. One thing that we were looking forward is possibly developing this Sensolite into something that can be used in the job industry. Knowing the impact that it can have in server rooms and chemical power plants, it is exciting and it makes sense to possibly develop a better version. Overall, this project has been a success, and we look forward to learning and working on bigger, better projects from what we have learned in developing Sensolite. Thank you guys so much for listening.